point-slope equations of lines. Now, if you're given a slope and a point, or if you're given 2 points, there are different ways of going about getting the equation of a line, but most people, at least most professors, at least at the college algebra level and above, want you to do point-slope form. And that's this equation right here. This is the point-slope equation of a line, and it's called that because inside of this equation is a point, x1, y1, and your slope, m. So they didn't like try to trick you with the name. The name has point and slope, and so does the equation. And so whenever we're given, like on this first example, we're given the slope is -3/4. It goes through a point, 4, -5. All we've got to do is plug in and figure out what the line is. So this is m, this is x1, y1, and we're putting it into this formula. So that gives me y minus y1, which is -5. And if you're on top of things, you can actually go ahead and change that and say that's really y plus 5, because 2 negatives make a positive. M is -3/4. And then in parentheses, x minus x1 gives us x minus 4. Now, if all they want is point slope, then we really would just need to clean this part up and make it y plus 5, and then we would be done. But let's assume that our professor actually wants us to write it in slope-intercept form. So this would be y plus 5, and then the first thing to do is to distribute this, so that we have -3/4 x, and then -3/4 times -4 is going to be +3. Okay, and if you need to use a calculator or work that out to the side, that's fine. But what's happening is that this is like 4/1, so the 4's are canceling each other out, leaving us with 3 from on top of this fraction. Now I just need to subtract the 5 over, and then I'll have y equals, which means I have slope-intercept form. So y equals -3/4 x minus 2. That wasn't too bad. The way they're going to try to make it not really worse, but it's just more work, is they can give us 2 points, which means we need to find the slope ourselves first. Remember, the slope equation is to subtract the y's over subtracting the x's. So it doesn't really matter necessarily which way we label this, but we have x1, y1, x2, y2. So my slope is -1 minus 3 over -3 minus a -2. So I'm just going to put plus 2. So on top I get -4. On bottom I get -1, which means that this is +4 for our slope. Now we're ready to plug into point slope, and the thing to realize is you can use either of these points to plug into this formula. It doesn't matter. I usually pick the first point just for like a consistency's sake, like it's x1, y1, might as well use it since it's already labeled that way, but you can use either point. So y minus y1 is y minus 3 equals 4 times x minus x1, so minus a -2 would give us +2. The key thing to remember when you're working this out is distribute first and then move whatever's next to y. So this is y minus 3 equals 4x plus 8. Add 3 to both sides. And we get y equals 4x plus 11. And that's our slope-intercept form. And again, it does matter. Your professor may be fine with you leaving it in slope-intercept form, which would have been this answer right here. But if they want you, point-slope form. If they want you to leave it in point-slope form, you'd be done right here. Otherwise, you'd want to keep going until you got slope-intercept form.